this is part 2 of the multiplication and division of decimals notes for the Health Science Bootcamp for Broward College. This part we're going to discuss division with decimals, and in part 1 we discussed rounding and multiplication with decimals. So now when you're dividing decimals, again, the chapter that we look at for this has already talked about negative and positive numbers. So the first and last step is going to be talking about the sign of the quotient, but in all of health science, we will not use signed values. All the values will be positive. So now, the problem with dividing numbers that have decimals is if the decimal is in the divisor, you want that divisor to be a whole number. So you want the divisor to be the whole number. Now, whether the dividend is a whole number or not, that doesn't really matter, but we want the divisor to be a whole number. So remember, it's dividend divided by divisor, or if we write it as a fraction, dividend divided by a divisor. So the first real step is going to be making the divisor a whole number by moving the decimal place all the way to the right. So now count how many spaces you had to move it, and you do that same move to the dividend. Once your divisor is a whole number, so it doesn't have any decimal parts, then you can do the division. Now we're going to do the division with long division. So when we were doing long division, we would ask, what do I need to times by? We would do the timesing, then we would subtract and bring down. Here, I guess in the last chapter, what we did was we stopped when we had a remainder, a number that couldn't be divided. We were like, hey, we'll just stop, we'll call it a remainder. But what we're going to do today is we're going to keep going. And to keep going, you tack on more zeros after the decimal place. So even if your dividend has a decimal in it, you can still continuously tack on zeros. Now, for rounding purposes, because some of these answers might be irrational, meaning they go on for a really long time with no pattern, we're going to round to 2 decimal places if needed. And you can recall from the first part of this decimals chapter that to round to 2 decimals, we'll need 3 decimal places. Why do we need 3 if we're only rounding to 2 decimal places? Well, because rounding, you have to look to the digit to the right and use that to decide if you're keeping or bumping. So we need that 3rd decimal place, but we're not going to go past 3 decimal places because some of these could get very, very long. We're going to start small. So we're going to do 15 divided by 4. 15 divided by 4. Now you're probably thinking, there's no decimals in this problem. But let's start without decimals and do a problem that would normally have a remainder, but instead we're going to make it a decimal answer. So 15 divided by 4. The 4 goes on the outside, and the 15 goes underneath. So the 15 is the dividend, 4 is the divisor. So we're going to say, hey, what number do we need to multiply 4 by to get close to 15? So we know 4 times 3 makes 12. So we'll put the 3 upstairs and the 12 downstairs, and we'll subtract that 12. So we've got 3 left over. Now, again, in the chapter on dividing whole numbers, we'd stop here and we'd say, okay, the answer is 3 with a remainder of 3. But what we need to do is now create a decimal so we can give a number which has 2 decimal places, or up to 2 decimal places. So what I'm going to do is I'm going to add a decimal place, and I'm going to put it right above upstairs, and I'm going to tack on a 0. And that 0 is going to come down. Now you'll notice when it comes down, the decimal place does not come down. So once you've marked that decimal place, that's it. You don't have to move it or think about it anymore. It's there. So now we'll think, okay, what do I need to times 4 by to get close to 30? And I know 4 times 7 makes 28. So I'll put the 7 upstairs and the 28 down here for subtraction. 30 take away 28 is 2. Now, I can't make 4 go into 2, so I'm going to tack on another 0, and I'm going to bring that down. So now I ask the question, what do I times 4 by to get close to 20? Well, 4 times 5 actually makes 20. So the 5 goes upstairs, the 20 is downstairs for subtraction, and I subtract and I get 0. And remember, if you get 0 and there's no other digits, you can stop. So 15 divided by 4 is 3.75. Let's try it again. 27 divided by 5. So 27 divided by 5. So we're going to think, what can I times 5 by to get close to 27? Well, I could times it by 5. That would make 25. So 5 goes upstairs as part of my answer. 25 is downstairs to subtract. So 27 minus 25 is 2. Now 5 can't go into 2, so I'm going to put a decimal in my dividend and upstairs in my quotient, and I'm going to tack a 0 on, and I'm going to bring that 0 down. So I say, okay, what do I need to times 5 by to get close to 20? And I'll say, oh, that's 5 times 4. So 4 is going to go upstairs, and 20 is going to go downstairs for subtraction. 20 take away 20 is 0, so I can stop. So we're either stopping when we get 0, or we're stopping when we have 3 decimal places in our quotient. So 27 divided by 5 is equal to 5.4. Let's try another one. 100 divided by 3. 100 divided by 3. What do I need to times 3 by to get close to 10? So 3 times 3 makes 9. So 3 goes on the top, 9 goes on the bottom, and I subtract. I get 1 left over, and I'm going to bring my 0 down. What do I need to times 3 by to get close to 10? Well, 3 by 3 would make 9, which is awfully close to 10. So 3 goes upstairs, 9 goes downstairs for subtraction. Now, 3 can't go into 1, and I don't have any more numbers to bring down. So I'm going to add some more numbers to bring down. I'm going to add a decimal place, which you put in the dividend and the quotient. And then I'm going to tack on a 0, and I'm going to bring that down. So I have 10. So what do I times 3 by to get close to 10? Well, 3. So 3 goes upstairs, 9 goes downstairs for subtraction. 10 take away 9 is 1. And now I need another 0 to bring down. Let me move these guys so I have a little bit of room here. I don't want to squish them, so I'm just going to move them over to the right. Oh, I just changed them all to a different color. Sorry about that. All right. Oh, it moved it. 3, 3, 3. Okay. So now we've got to add another 0 to bring down. So I'm going to bring down, I'm going to give out another 0 here. I'm going to bring it down. I get 10 again. So I'm like, what do I times 3 by to get close to 10? Well, times by 3. So 3 times 3 makes 9. 9 goes downstairs. 3 goes upstairs. So now I need 3 decimal places. So I'm either going to stop at 3 decimal places or I'm going to stop when I have 0. But I don't have 0. I have 1. So I have to bring down another 0. Whoa. That makes another 10. And I do this problem one more time. What do I times 3 by to get close to 10? I times by 3. So 3 goes upstairs, 9 goes downstairs. I can do this subtraction, but I'm just going to stop because I have 3 decimal places. Now, again, why did I stop at 3 decimal places? Well, because I wanted to round to 2 decimal places if needed. So the third space tells me whether to keep or bump. So what I've got here is 33.333. I'm rounding to 2 decimal places, so that's here. I'm going to look to the right. So my right number is 3, which means I'm going to keep the 3. So my final answer will be 33.33. And that is an estimation because I cut off a decimal. Okay, let's try another one. 97 divided by 9. So what do I times 9 by to get close to 9? I times it by 1. 9 times 1 makes 9. 1 up here, 9 down here, subtract. That leaves 0. I'm going to bring down the 7. let me just make it look a little nicer. So bring down the 7. What do I times 9 by to get 7? If I times by 1, it's too big. So we'll do 9 times 0, make 0. So I'll put the 0 up here and do the subtraction. I still have 7, but now I can start tacking on 0. So I'm going to put a decimal place in my dividend and my quotient. I'm going to tack on a 0 to bring down so I can do some math. So what do I times 9 by to get close to 70? Well, I could times 9 by 7. That would give me 63. So 9 by 7 makes 63. So 7 is going to go upstairs and 63 is going to go downstairs to subtract. So 70 minus 63 is 7. I'm going to tack on another 0 because I'm only stopping if I have 3 decimal places in my answer or I get 0 when I do subtraction. So I'm going to tack this 0 on, and I'm going to do the same question. What do I multiply 9 by to get close to 70? Well, it's still 7. So 7 goes upstairs, 63 goes downstairs, and I subtract to get 7 again. So I'm going to tack on another 0. And I'm going to do it one more time. So what do I times 9 by to get close to 70? Well, still 9 times 7 makes 63. So I'll put 63 here. And sure, when I do the subtraction, I get 7. But I can stop because now I have 3 decimal places. So my answer is going to be 10.77 or 10.78 because I'm rounding to 2 decimal places. I look to the right. To the right is a 7, which tells me to bump up. So my answer would be 10.78. So now we're going to do 2 problems which are a little longer, but I want to show you some that don't have a multiplication table that you really have to think. So these last 2 problems in division by decimals are really going to give your brain a workout, and you want to make sure that you're bookkeeping very carefully so you don't mess up any math. So the first thing you're going to notice here is that in problem E, both of my numbers are going to have a decimal. So 2614.5 divided by 41.5. So we want to focus on this number here. We want this to be a whole number. So in order to do that, I need to move the decimal 1 digit to the right. So I'm going to move the decimal 1 digit to the right in the dividend. And now I can do my math. So 415 goes into 26145. So remember, I moved the decimal to the right and it happened to make a whole number. Cool. So now what are we going to do? We're going to do the math. So what, let's see, before I ask that question, I can't make 415 go into 2. I can't make it go into 26. I can't make it go into 261, but I can make it go into 2,614. So let's see. Now here, we're just going to guess, right? Like, let's guess 5. So on the right here, I'm going to do a couple think steps. 415 times 5 would be, let's see, 5 times 5 is 25, carry the 2, 7, 5 times 4 is 20. 2075, so 2075. That's not really that close to 2614. So let's do 415 times 6. Now, if you don't want to do the multiplication, you could just add 415 to 2075, but I'll do the multiplication. So 6 times 5 is 30. 6 times 1 is 6, plus 3 is 9. And then 6 times 4 is 24. Hey, that's perfect, right? 2,490 is pretty close to 2,614. So what do I need to times by? Now this is important. Look where I'm putting my 6. I'm putting it right over the 4 because I had to use all 4 of those digits. So 6 times 415 was 2,490. And now I need to subtract. So now subtracting by hand, if the number on top is small, you're going to borrow 10 from the digit to the left. So 4 minus 0 is 4. Now I can't do 1 minus 9. So from the 6, I'm going to change it to 5, and then I'm going to make, instead of having 1, I'll have 11 because I'm borrowing 10. So 11 take away 9 is 2. 5 take away 4 is 1. And 2 take away 2 is 0. So now I need to bring down the 5. Now I have to decide what number do I times 415 by to get 1245. Well, what if I try 3? So over here I'm going to see what happens if I do 415 times 3. So 3 times 5 is 15. So carry the 1. 3 times 1 is 3, plus 1 is 4. 3 times 4 is 12. 1245. Hey, that's right on the nose. So 1245, and I timesed by 3, and when I do my subtraction, I get 0. And when your subtraction leads to a 0 and you have no other digits, you can stop. So that's kind of cool. This one started out with 2 decimals, right? 2,614.5 divided by 41.5. And it came out to a nice whole number, 63. Let's try one more of these tough ones where it's not numbers from your multiplication chart, so you're having to do these think steps over to the side because you don't get to use a calculator to decide your answer. You have to do it by hand. So step 1, we need to make sure that our divisor is a whole number. So we need this whole. And to do that, I need to move the decimal 1 to the right. So I'm going to do that in my dividend. I'm going to move it 1 to the right. So the problem becomes 54219.5 divided by 273. So let's put that into a division, a long division chart here. 5,400, so 5,000. 54,219.5 divided by 273. Now, in this problem, there's already a decimal place, right? Even though we killed that decimal in the divisor, the dividend still ended up with a decimal. So when your dividend ends up with a decimal, you're going to bring that decimal upstairs to the answer where the quotient goes, right above it, which is why it's really important to line things up. Okay, so I can't make 273 go into 5 or into 54, but I can make it go into 542. Now, let's see, is it going twice? I don't know. I'll do a think step over here in my margin. 273 times 2. 2 times 3 is 6. 2 times 7 is 14. Carry the 1. 2 times 2 is 4 plus 1 is 5. 546. Oh man, that's too big. So it must be 1. So right above this 2, I'm going to put a 1. And then I'm going to multiply 273 by 1. And that's what's going to go under here for subtraction. So 542 minus 273. Remember, if you need to borrow, you borrow 10 from the digit to the left. So I can't do 2 minus 3, so I'm going to borrow 10 from this 4. So 12 minus 3 is 9. Now I need to do 3 minus 7, but I can't do that. So I have to borrow from this 5. 13 minus 7, ooh, I could do that. That's 6, and 4 minus 2 is 2. So I couldn't make 273 go into 269, so what I need to do is bring down the next digit, which is a 1. So now I want to decide, what do I need to multiply 273 by to get close to 2,691. Now, you know some facts about multiplying by 10. So you know 273 by 10, you don't even have to do the work. It'll make 2,730. And that's too big. So odds are I'm going to have to multiply by 9. So let's do it over here. 273 times 9. 9 times 3 is 27. 9 times 7 is 63, plus 2 is 65. 9 times 2 is 18, plus 6 is 24. Ooh, that's lower. So we're going to do 273 times 9, which is going to make 2, 4, 5, 7. We'll put the 9 upstairs. We'll put the 2,457 downstairs, and we'll subtract. Okay, gotta borrow. I can't do 1 minus 7, so I'm going to borrow 1 from the 9 to make 11. So 11 minus 7 is 4. 8 minus 5 is 3. 6 minus 4 is 2, and 2 minus 2 is out. Now I'm going to drop down the next digit, which is a 9. So now with what we just did, multiplying 273 by 9, that made 2,400-ish. And we don't want a number that big, right? It has to be less than 2349. So let's try multiplying by 8. So let's try 273 by 8. See, 8 times 3 is 24. 8 times 7 is 56, plus 2, 56, 57, 58. 8 times 2 is 16, plus 5 is 21. Perfect. So I'm going to do 273 times 8, and that's going to give me 2,184. That 8 goes upstairs. Now, that 8 corresponded to when I brought down the 9. So that 8 has to be right over the 9, which is next to the decimal. Okay? So now we have to do the subtraction. 9 minus 4 is 5. 4 minus 8, ooh, I can't do that. I've got to borrow. So I'll call this 2, make that 14. 14 minus 8, that's 6. 2 minus 1 is 1, and 2 minus 2 is out. And now I have to bring down this 5. So I want to multiply, or I want to find the number that I have to multiply 273 by to get close to 1655. Now let's think here. So multiplying by 8 gave me 2,000. So 8's too big. 7 would probably be too big. Let's try 6. So again, we're just going over like in the margin over here, and we're trying 273 times 6. So 6 times 3 is 18. 6 times 7 is 42, plus 1 is 43. And 6 times 2 is 12, plus 4 is 16. Hey, that's super close. Booyah! So I'll put 1638 here. That corresponded to a 6 here. And then I'll subtract. So I can't do 5 minus 8, so I need to borrow. So 15 minus 8 is 7. 4 minus 3 is 1. 6 minus 6 is out. And 1 minus 1 is out. So that difference was just 17. Now I can't stop because I have to round to 2 decimal places. So I will need 3 digits after the decimal. So we're going to have to do this 2 more times. Since I don't have any more digits, I'm going to tack on a 0 and bring that down. Oh man, that just makes 170. What number do I times 273 by to get 170? Well, we can't actually do that, right? 170 is small. So we would do 273 times 0. So that gives me 0 up here, which gives me, and I multiply 273 by 0, I subtract, and I still have 170. Now I need another 0 to bring down. This is going to be my last one because then I'll have 3 decimals. So now we need to get close to 1700. I think that's 273 times 6. So remember, we did it here. 273 times 6 was 1638. That's pretty close to 1700. So let's do it again. 273 times 6. So I'll put a 6 here, and I'll put 1638 here. See how we have so much room in this box? I'm going to do that subtraction, and I'll get a number, but I don't actually care. Like, I can stop now because I have 3 digits. So now my answer is 198.606, and there's stuff after that, but we're not going to do it. We stopped because we only wanted 2 decimals. So the answer will either be 198.60 or 198.61. I have to look to the right. So to the right is a 6. That tells me to bump up my 0. So my final answer is 198.61. Now, just like in regular multiplication or regular division of whole numbers, you can also check using multiplication. So part F is really like the longest a problem would be. Most problems that you're going to encounter at work are going to have timesing and dividing by 10, and then smaller numbers. You're not generally going to have to do long decimal division like this, but it's good to know just in case it does come up. So now the last concept is about dividing by powers of 10. So in multiplication, we moved the decimal to the right. In division, we move the decimal to the left. Okay, so 13 divided by 10. So now 13, technically its decimal is right there to the right. Since I'm dividing by 10, and 10 has 1 0, I'll move my decimal 1 space to the right. My answer will be 1.3. That has to feel so refreshing after that last problem. Let's try again. 9,687 divided by 100. So 100 has 2 zeros. So I'm going to have to take this decimal place and move it 2 to the left. So my answer would be 96.87. Let's try one more. 2,563 divided by 1,000. Oops, 1,000. So 1,000 has 3 zeros. So I'm going to have to take this decimal and move it back 3 spaces. So that would give me 2.563. Now this one did not say to round, and it wasn't a crazy long decimal, so we would just leave it just like this.